Okay guys, welcome back to a new IMONST video. So we're almost done with the sample 3 papers. Now we're left with seniors problem 19 and 20, which are inarguably the hardest problems of this whole paper. So let's look at problem 19. Here for problem 19, I'll provide two solutions, one a proper one and the second an improper one, so don't follow the second solution, okay? Now, let x and y be real numbers with the absolute value of x minus y plus the absolute value of x plus y equals to 2. So determine the greatest possible value of x squared plus y squared minus 9y. So what we want to do with x squared plus y squared minus 9y is we'll do a bit of altering, so change a bit of stuff. So yeah, if you guys know it, it's completing the square. So we will have x squared plus y squared minus 2, 9 over 2, and then y, then plus another, plus another 9 over 2 squared. Then we need to minus it back because this whole thing is 0. We just created this out of nothing. So we will have an x squared plus y minus 9 over 2 squared minus 9 over 2 squared. Okay, so this is what we want to find, simplified. Okay, and then if we want to find the graph of this, we need to know one thing first, that is x minus y itself is larger than or equal to 0 when x equals to y. So we also know that x minus y squared is also larger than or equal to 0, so we can just square it. So squaring both sides, we would have square of absolute x minus y plus, okay, x plus y, this whole thing squared equals to 2 squared. We would have x squared minus 2xy plus y squared plus x squared plus 2xy plus y squared. Then we have a plus 2 x plus y and then times absolute x minus y equals to 4. Now, cancelling these two, we would have 2 x squared plus y squared plus 2, this thing is x squared minus y squared, equals to 4. Now we can divide both sides by 2, so we would have an x squared plus y squared plus x squared minus y squared equals to 2, right, this thing. So we kind of move down a little bit. Okay, so up a little bit because we need to see this. Now, this x squared minus y squared in the absolute value function, it will have two possibilities. So this thing could either be x squared minus y squared. It could also be y squared minus x squared when it comes out of the function. So when does this happen and when does this occur? So x squared minus y squared absolute is equal to x squared minus y squared when the absolute value of x is larger than the absolute value of y. And then x squared minus y squared in the absolute value is equals to y squared minus x squared when otherwise, so meaning absolute value of y is larger than the absolute value of x. Okay, so we need to consider two possibilities, and then from this one we would have x squared plus y squared plus x squared minus y squared equals to 2, 2x squared equals to 2, and then x squared equals to 1. But x squared equals to 1, we can turn it into x equals to positive or negative 1, right? Because negative 1 squared is still 1. And then, again, note that y, the absolute value of y, is smaller than the absolute value of x, okay? And then the second one, so if x squared minus y squared absolute is equals to y squared minus x squared, it will give us x squared plus y squared minus x squared equals to 2, which would give us 2y squared equals to 2, y squared equals to 1, then again y equals to positive negative 1, then again, so this time the absolute value of y, which is 1, is larger than the absolute value of x. So here it would be absolute value of y smaller than 1, and then this one will be absolute value of x smaller than 1, right? So if we want to draw a graph out, we will do something like this. So this is the xy axis. Then we need to pinpoint out the points. Okay, so this is 1, this is negative 1, this is negative 1, and then this is 1. Okay, so we have two cases, right? So we would have x equals to positive or negative 1, so these lines. But then note that the absolute value of y is smaller than 1. So something like this. So yeah, until here. Okay, and then the next case would be y equals to positive or negative 1, but then the absolute value of x is smaller than 1. So it'll be something like this, and then like this. So we would have our square. This is a square, the graph. Okay, so finally, we want to find the maximum value of x squared plus y minus 9 over 2 squared minus 9 over 2 squared, which is this one. So to do that, our x, we could put it either at -1 or put it at a 1. So we could have x equals to 1 or -1. Then our x squared will be equal to 1, right? And then for, okay, give me a few seconds. So we also know that since x equals to 1 or -1, it means it will be on, where is it? It will be on this case. And then we know that the absolute value of y is smaller than 1, which means y is smaller than 1 or larger than -1. Wait. Oh, I forgot something. This one should be sorry, this is my bad, but this one is smaller than or equal. This is y's absolute value is smaller than or equal to 1, and then this one is x's value is smaller than or equal to 1, because when x equals to y, x squared minus y squared equals to y squared minus x squared equals to 0. So this is my bad. Okay, so this put an equal sign over here. And then since we want a y minus 9 over 2, we would have a y minus 9 over 2 is larger than -11 over 2, and then it is smaller than or equal to -7 over 2. But if you put in absolute values, this one is actually bigger. So we want our y minus 9 over 2 square to actually be -11 over 2 square, which is 1 to 1 over 4. Now 1 to 1 over 4 minus 9 over 2 square, which is 81 over 4, is 40 over 4, which is 10. So the max value, as we can see up here, so since this one's max value is 1, this one's max value is 10, so 1 plus 10 equals to 11. So the answer to question 19 here is 11. Okay, so I hope you got it right. Now, this second solution, please do not follow this. This is not a very good way. Okay, okay. So what you will do is you would go to Wolfram Alpha and then look at the question. So we have absolute x minus y plus absolute x plus y equals to 2, and then just type it into the equation, and then it will it will draw a graph for you. Okay, so it's this one, right? So we would have this one. Okay, so our graph would look a bit like this. This is our graph, exactly like our square, right? So of course, this is the second solution, and then you just find any point. Okay, so yeah, do not do this. Now let's move on to question 20. Okay, sorry guys. So now I've added two xy axes at the right because it will facilitate us in our problem solving process. So at question 20, we need to see. Consider the two-dimensional coordinate plane. So as we can see here, yeah, this is our x and y axes. For any positive integer n, define fn to be the number of lattice points on the line segment connecting point 0, 0 to point n plus 6. Line segment meaning that it does not exceed these 2 points, and then excluding both endpoints. Find the value of f1 plus f2 plus f3 plus all the way till f1000. So one main thing I would like to bring out here is that the main concept we'll be using would be GCD, the greatest common divisor, or HCF, highest common factor. So you can think of it like, say, 9 over 18, right? Since both can be divided by 9 to become 1 and 2 in a fraction, so the GCD of, say, 9 and 18 would be 9, something like this, okay? Now, if two numbers cannot be reduced, like say 5 and 7, this is already an irreducible fraction. GCD of 5 and 7 would be 1, okay? Now, let's take an example. Say I want to find f9, right? I'll put f9 right here in the xy axis. So we have 0, 0 over here, 9, and say 9, 15. So something like this. Alright, so we have 9, 15. Now, here, since we know that not both 9 and 15 can be divided by 3, so if we put it on a fraction, we'll have, so this line segment is part of the line y equals to 15 over 9x, right? Which is equal to 15 over 9 is equal to 5 over 3 equals to 6, no, equal to 10 over 6, right? So as you can see, for 3, 5, they also lie on the line. For 6, 10, it also lies on the line. So in total, there are 2 lattice points excluding both endpoints. So for F9, the value would be 2. So something like that. Now we want to find this for 1,000 value. So how do we do this? Now notice that we need to use a GCD, right? So let the GCD, the greatest common divisor, the GCD of n plus 6 be A. Okay, so the GCD of n plus 6 is equals to the GCD of n and 6. Why? Because you can minus an n here. Because, okay, so from this we can simplify by a lot. Why? Okay, so as we can see, 6, the factors of 6 include 1, 2, 3, and 6, right? So we can divide this into 6 cases. So for any f6k plus 1, and then for any f6k plus 2, f6k plus 3, f6k plus 4, f6k plus 5, and then f6k plus 6. Now, basically, the function f represents the GCD, where fn equals to GCD of n and 6 minus 1. Because as you can see in the example that I've shown, so for f9, the GCD of 9 and 6 is 3, and then we minus 1, so we get 2, right? So, you guys can kind of make up how this came to be. I won't be explaining much here, but basically we can divide this into 6 cases. Why is this so? Because we can make something like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we can list out all of these until it reaches 1,000, which lies on 6k plus 4. Okay, so 6k plus 1 and 6 do not have any common factors, because if you put like 6 over 6k plus 1, it's just there, it's irreducible. So it will be 1 minus 1 will be 0. And then for f6k plus 2, because 6 and 6k plus 2 both are multiples of 2, so we can divide this. So this is 3k plus 1. So if we divide by 2, we will have 2 minus 1 equals to 1. And for 6k plus 3, 6, and then 6k plus 3, we can divide both by 3, so we have 2k plus 1, we will have, yes, so the highest common factor is 3 minus 1, we'll have 2. So one example was the 9 just now. Then for 6k plus 4, we just put on the fraction, and then we just see how much we can divide both by. 3k plus 2 equals to 3 over 3k plus 2. Since we can divide both by 2, so the GCD is 2 minus 1, we'll get 1. Then 6 and 6k plus 5 are irreducible if we put on a fraction, so 1 minus 1 equals to 0. And for 6 over 6k plus 6 is just, we divide both by 6, we'll get 1 over k plus 1. So we'll have 6 minus 1 equals to 5. Now as you can see, this thing is like is periodic, meaning that after every 6 numbers, the whole cycle just repeats. And then as we know, so we can do some long division. So 1000 divided by 6 is 166. We minus 996, we get a 4 over here. Okay, sorry, let me move down a little bit. So 1000 minus 996, we get a 4 over here. So 1000 equals to 166 times 6 plus 4. So what we want to do is, we know that f1 plus f2 plus f3 plus f4 plus 5 plus f6. Okay, this one would be 0 plus 1 plus 2 plus 1 plus 5 plus 0. No, plus 0 plus 5 would be equal to 9, right? So, and then we know that f7 plus f8 plus f9 plus f10 plus f11 plus f12 is the same as above, so it will also be 9, and then the next row will also be 9 and above. Now we can have 166 rows of these, so 166 times 9 is 1494. We are very close. Now, we just need to count. F997 is also equal to F1, F998 is equal to F2, F999 is equal to F3, and F1000 is equal to F4. So if we count this, just count another 1 plus 2 plus 1. So plus 1 plus 2 plus 1 will be equal to 1498. And indeed, this is the answer for question 20. I know this might sound a bit strange for you guys, but basically, using GCD, we can just find all of these. And then you might be asking why use GCD. Because think of it. Your fraction, your normal fraction, like the 15 over 9 that I just gave you, is equals to 5 over 3 is equals to 10 over 6. Now these points all lie on the line segment, right? That's why you will be using GCD. I know this question might be a bit confusing for most of you. So if you guys have any problems, you guys can just write down in the comments, and then I'll just try my best to reply all of them. So for now, we have completed IMONST sample 3. So for the next series, we'll be discussing the last year's questions. Okay, last year's junior and senior. Okay, so see you guys then. Bye bye.